Hello friends, today we'll be using scipy for finding out the roots of any high degree polynomial. There are several functions available in scipy to perform this task. We'll be looking one by one these functions and try to find out the roots using these functions. So what is scipy? Scipy is basically a Python module developed to perform scientific computations. And the best part is that we needn't have to write full-length code for each and every method for doing that. So first, let us write a function for the given polynomial. We will be using def. Let's say fn is the name of the function which is taking argument x and it is returning x square minus 5x plus 4. Now, once the function is developed, why not to plot this also? So we'll be using matplotlib, pylab. So pylab import everything, and then we'll be creating an array of x. So we'll be using linspace function. So let's say we are starting with -10, ending at let's say 15, having 10 data points, and yes, use this function plot. So fn, pass this argument. Let's say we want it to be in red color. So this will be your function. Let us increase the number of data points more so that it becomes much more smoother. Okay, now if you look this particular, so this particular curve or this particular function crosses 0 line. So if I draw the grid also, so this is crossing 0 line at 2 points. These 2 points are between 0 and 5. So our roots, so this is a polynomial having degree 2, so it must be having 2 roots. So this is close to 0 and this is close to 5. So let us try to use scipy for performing this root finding task. So the first thing which we will be using is the Newton-Raphson. The function name itself is Newton. So we'll be using this. So this Newton function accepts 2 arguments. So the first argument is the function itself, and these, let me write fu only, function itself, and the second argument is the initial guess. So let us use Newton-Raphson to find out the roots of the polynomial which we have taken as x square minus 5x plus 4. So the method goes like this. You simply write Newton, then pass the function to it, and then the initial guess. So let's say my initial guess is 0. Okay. So the mistake which I have done is, though I am using scipy module, I have not used it. I have not imported it. So I'll be using from scipy.optimize, then import all the functions, let's say. So now you can very well appreciate the fact that this is very much efficient in giving me the roots which are very close to this initial guess 0. So if let me print this, and if I want to get the another root, that is the one which is close to 5, so let me give this 5. So there is my second root, 4. So the first root is 1, the second root is 4. So let us take another function here, which is basically known as bisect. So this is basically coming from the bisection method. The function takes 3 arguments. The function itself, the bisection function takes 3 arguments, function. Then the range in between which we are expecting the roots to lie. So this is initial one, that is the left value, and then the right value, let's say. So if I am interested in knowing the root which is lying between, let's say, 0 to, let's say, 3, is there any root? If there is any root, then it must be giving that particular root to us. So let us use this function, that is bisect, and then pass the function, then left value. So let me take the left value as 0 and the right value as 3. So 0 and 3. So it is returning me the 1, the same which has been returned by Newton function. So if I am interested in knowing what is the root between, let's say, 3 and 7, so it will be returning me the second root. Now here, let's say I am choosing minus 10 to minus 5. What will happen? Let us see. Minus 10 to minus 5. So this is giving some error saying that must have different sign. So you all know bisection method only works when the output or when the value of the function for these two given inputs is different. Then only root will be lying in between those, otherwise not. So that's why this error is simply telling me that there is no root in between minus 10 and minus 5. So if I change this minus 5 to, let's say, 3, then definitely I will be getting that 1. So in this way, we can find the root with the help of bisect function. There is another function known as root itself. The function name is root, and this takes two arguments. First, the function itself, and second, the list of numbers or the initial starting guesses in between we are expecting the roots. So let's say I am saying I want to know all the roots which are between minus 5 and to 5, let's say. Then let us see what happens. So I am passing the function, I am passing the list, that is minus 5 to 5, and run it. So this is returning me all the attributes, but I am only interested in the roots itself. So method.x. So this will be returning all the roots which are lying between minus 5 and 5. So this is again a sort of an extended version of bisect method. And the last one is fsolve. This is again very much similar to the previous one, but this is often used because of its efficiency. So fsolve fsolve. Now this function also accepts the polynomial function and the list in between you are expecting the root. That means, let's say I am interested in minus 5 to 5 again, and let's see what happens. Passing the function, then the list to it, minus 5 to 5. Yeah, we got 1 and 4 as the roots of this polynomial equation. So in this particular lecture or video, what you have learned is that there are ways which you can use to efficiently evaluate the roots of any given polynomial. So the one which we have discussed in today's class is basically the Newton function, bisect function, root function, and fsolve. Hope that you have learned a lot. Thank you very much for watching it.